Welcome to class today. Today, let us continue with our revision on the chemistry, the topics you are expecting in the WAEC exams. Today, I'll be dealing with three major topics. All right, I'm going to deal with the atomic structure and the periodic table. All right, under the atomic structure, we talk about the atomic number, the mass number, how to know the number of protons, electrons, and neutrons in an atom of an element. That's atomic structure. We'll be talking about the periodic table. All right, how to identify the metals and non-metals. And if you stick around to the end of this video, I will also be talking about solubility. If you have not seen the first part of this revision class, please go and check it. Drop the link rather in the description to this video. And I'm still going to do other topics in this revision towards your exam. I'm still going to deal with organic chemistry. I'll talk about some other topics. Now, come with me. Let's look at the topic or the question on the board on atomic structure. Number one, it's important to understand that an atom is made up of particles, right? Now, inside, this is how the atomic structure looks like. This outer part is called the orbital or the shell. And that is where electrons are found. Now, this inside is called the nucleus. Inside this nucleus, there are two particles there. We have the proton, which is positively charged. You have the neutron, which is what? Carrying what charge? Is it neutral or what? Okay, if you have said neutral, you are wrong. It is no charge. Neutron has no charge. Okay, not neutral. Okay, no charge. No charge means it's neither positive nor negative, all right? But when you say neutral, neutral means equal positives and negative charges. So it is no charge. I hope that is clear. I've spoken about the proton, which is positive, the neutron, which has no charge. Then there's a third particle called the electrons, and the electrons are negatively charged. They are located on the orbital or the shell. The next thing we talk about, let's quickly talk about mass number and atomic number. Atomic number is the number of protons present in an atom of an element. Atomic number is the number of protons present in an atom of an element. That's number one. Another thing about atomic number is the position of an element on the periodic table. So the atomic number determines the position. It is the position of an element on the periodic table. Therefore, hydrogen is occupying number one on the periodic table. It's the first element and it has atomic number 1. Sodium is number 11. It has atomic number of 11. Calcium is number 20. All right. Potassium is number 19. Magnesium is number 12. So that is atomic number, and it tells you the number of protons. So therefore, magnesium will be having atomic number 12, and number of protons will be 12. Calcium number 20, the number of protons will be 20. So that is atomic number. While mass number is the sum of protons and neutrons. They can ask you to define all of this. So sum of protons and neutron. Proton and neutron. That means your mass number is neutron plus proton. Neutron plus proton. So if you look at the mass numbers that you have here, they are gotten by adding the protons and the neutrons together. Now it's also important to note that there are equal number of protons and electrons in a neutral atom of an element. Let me repeat that. There are equal number of protons and electrons. Protons are positively charged. Electrons are negatively charged in a neutral atom. That was why I said earlier that neutral means equal, positive, and negative. All right, so what do I mean? Now, so if I have sodium and I have Na+, they are not the same. This sodium is a neutral atom of sodium. This is not a neutral atom because it's carrying a positive charge. So a neutral atom here, you are not seeing any charge here, all right? But by the time you analyze this, it has equal number of protons, positive protons, and negative electrons. While this, there is an excess proton and a shortage of one electron. We're still going to talk about that. So when we talk about, so I said, note, there are equal number of protons and electrons. There are equal number of protons and electrons in a neutral atom of an element. Neutral atom of an element. Neutral atom of an element. So with that foundation that has been laid, let's try to answer this question. Here we have particles. These are ions. They are not neutral atoms. You have the mass number here. You have the number of neutrons. And you remember I told you the mass number is sum of protons and neutrons. So for us to get the number of protons here, you know, neutron plus proton is mass number. So if the neutron is 12, all you need is to remove 12 from mass number 24 and you get 12. So there are 12 protons here. So if there are 12 protons here. Now let's get to know the number of electrons. This W2 plus means it has given out 2 electrons. It has lost 2 electrons. Anytime an ion is carrying positive charge, it has lost electron. It has given out. Givers are positive, borrowers are negative. So the fact that this guy is carrying 2 plus means it has given out 2 electrons. So originally, there were meant to be equal number of electrons from what I said here. Equal number of protons and electrons in a neutral atom. So originally, this guy had 12 protons and 12 electrons. But because it has now given out 2 electrons, so the number of electrons here will be 10. Because it's deficient in 2 electrons, it's giving out 2 electrons. Right. Now let's come over here. We have the mass number here. We have the number of protons. So let us get to know the number of neutrons. So the number of neutrons will be remove protons from mass number to give you the number of neutrons. So there are 8 neutrons. That's 16 minus 8. That's going to be 8 neutrons here. Now naturally there is meant to be 8 protons and 8 electrons, equal number of protons and electrons. But because this negative means it has borrowed 2 electrons. So there is an excess 2 electrons, 2 negative electrons that we do not have a positive to cancel it out. That is why it's carrying the 2 minus. So here there are 2 extra electrons. So instead of 8 electrons, it's borrowed 2 to make it 10. So here is going to be 10 electrons. So this element has 10 electrons. Are we together now? So because there's an excess. So the minus is the excess, but it has borrowed it. While this, it has given it out or lost it. All right. Now note also, it is only the number of electrons that can change. If you look at the structure I've drawn here, the proton and the neutron, they are inside the nucleus, so nothing changes them. Except for maybe a radioactive reaction or nuclear reaction. But here, for normal chemical reactions, it's only the electrons that take part in reaction, and not just electrons alone, the electrons in the outermost shell. So it is the number of electrons that can change. They can decrease or increase. And the reason why elements will take part in reaction is to attain octet valency. They want to have 8 electrons in the outermost shell. They want to attain stability by either giving out electrons or accepting or borrowing electrons. Is that okay? Now, let's go to the next question. Here, the mass number is 27. And then we have the number of electrons. Because this is a neutral charge, neutral atom, right? There are equal number of protons and electrons here. So if we have 13 electrons, there will definitely be 13 protons here. And then to get the number of neutrons, just remove the number of protons from mass number, you get the number of neutrons. So 13 from 27 will give you 14 here. And then for the last answers to the question, this is still a neutral atom. There will be equal number of electrons and protons. So here, if there are 11 electrons here, there are also 11 protons. And of course, to get the mass number is the sum of protons and neutrons. So if I'm going to add this protons and neutrons together, 12 plus 11, that's 23. So here is 23. And with that, we've been able to answer this question. So I want to believe you understood everything I've said here. But if you still want to understand better atomic structure, I have a video on that. You can go to the comment section and request for it, and you will actually get the link right there. Or you can go to my YouTube channel and check it out. All right, now let's go to the next question. Here you have a list of elements J, Q, R, X, Y. We were given the atomic number and the mass number. The first question says, which of these elements is a halogen? Then which is most likely to be attracted by a magnet? Which belongs to group 1? Which would readily form an ion with a double negative charge? Then what type of bond would exist between J and X when they combine? How many neutrons are there in Q? Write the formula of the compound form when R combines with X. Then state the element which exists as diatomic molecule. Then select the element which belongs to the D block of the periodic table. So to answer this question, this is a combination of different topics in one. Yes, it looks like this is a periodic table question, but there are other topics that are connected, and that is why periodic table is very important. It is the foundation, the basis of understanding chemistry. If you understand the periodic table, you will understand most part of chemistry. So if you have not seen my video on the periodic table, I dropped the link in the description to this video. You see there. Go and watch it so that you can understand. Now, to answer this question, the easiest thing to do is to write out the electronic configuration of each element here, and it will help you to answer many questions here. So how do I write the electronic configuration? I'm going to use the atomic number. You remember I told you earlier, the atomic number is the position of an element in the periodic table. It is also the number of protons present in an atom of an element. And I said mass number is the number or the sum of protons and neutrons in an atom of an element. So for us to answer these questions, let's write out the element, then the configuration. So for this configuration, I will be dealing with the K element shell configuration. All right. So this element J, Q, R, X, and Y. So the configuration for J, because it has atomic number 9, is going to be 2, 7. 13 will be 2, 8, 3. 16 will be 2, 8, 6. 19 will be 2, 8, 8, 1. 24 will be 2, 8, 8, and 6. 2 plus 8, 10 plus 8, 18 plus 6, 24. So it's important to note this is the only transition metal in this group. All right, it's the transition metal. And then so now let's try to answer the question. They said which of the elements is a halogen? Halogens are elements in group 7. So which of them is in group 7? Mere looking at this, you would not be able to know which is in group 7. But if you go by this, to know the group an element belongs to, you make use of this configuration. So for J to X, we can make use of that configuration because they are part of the first 20 elements. So the number of electrons in their outermost shell, all right, this outermost shell, that is what determines the group it belongs. This is a group 7, group 3, group 6, group 1. So which of them is an halogen? Halogens are group 7 elements. So the correct answer is J. This is the halogen, is in group 7. So to answer this question, A, Roman figure 1, the answer which is an halogen is J. J is an halogen. Then which is most likely to be attracted by a magnet? That means which of them has the ability to attract a magnet? So the most appropriate answer will be that transition metal amongst them. Even though, yes, metals have ability to be attracted to, but very low ability. So, but when we get to transition metals, that is where they are easily attracted to magnets. So the transition metal there is Y, number 24, which is chromium. All right. So number 2, no, Roman figure 2 is your Y. That is the one that has the ability most likely to be attracted by magnet. Number 3, which one belongs to group 1? Which one belongs to group 1? Group 1, from here you can know this is the number of electrons in the outermost shell. So X belongs to group 1. Roman figure 4. Which one would readily form an ion with a double negative charge? Double negative charge. Negative, I said earlier, means they are borrowing 2 electrons to have 8 electrons in the outermost shell, or to attain stability, octet valency. So they have to borrow 2 electrons. So who amongst them needs to borrow 2? This guy has 6 in the outermost shell, so it needs to borrow 2 to make it 8. So the answer will be R. So this R needs to borrow 2 to attain octet. And then Roman figure. Okay, so let's go to question B. Question B says, what type of bond would exist between J and X? J and X. What is J? That's the non-metal, and our X is group 1 element, metal, potassium and fluorine. The kind of bond between the two of them is electrovalent or ionic bond. Is electrovalent or ionic bond. Why? This is the kind of bond between metals and non-metals in which the metal transfers electrons to the non-metal. And then Roman figure 2 here, how many neutrons are there in Q? How many neutrons? How do I know the number of neutrons in Q? Q, this is the atomic number, this is the mass number. So I will remove the atomic number, which is the number of protons, from mass number to know the number of neutrons. So the number of neutrons will be 13 from 27, that would be 14. So it's 14. And then the next, write the formula for the compound form when R combines with X. What is R? 286. All right. That means my R needs 2. Please look at this. Okay, 2886. Look at it. That means my R needs 2 electrons. And remember, it's a non-metal. So minus 2. So it has oxidation number of 2. And that should be sulfur. That's number 16. Needs 2. And X is number 19, potassium. It's positive. So X has oxidation number of 1, has 1 in the outermost shell. So anytime they react, they will connect, they will exchange the oxidation number. So it's going to be X2R1, X2R. Mind you, the metal comes first before the non-metal. So that is why X comes first. So X2R, not R2X, not RX2. If you don't write it correctly, you'll be penalized. So it's X2R. So the product that will be formed between them is X2R. So that's the formula of the compound formed when R combines with X. Then state the element which exists as diatomic molecule. Number 4. Diatomic molecule means 2 atoms. So the halogens are usually the ones that exist as diatomic molecules, the group 7 elements, and the answer is J. So J, fluorine exists, fluorine, iodine, chlorine, bromine. They have that ability to react together. All right, they are radicals, so they react together and they form diatomic 2 atoms, chlorine gas, Cl2, bromine, and then chlorine, like that. Now that's, and then the last, select the element which belongs to the D block of the periodic table. Elements in the D block are the transition elements. So the only element that will be in the D block from all of this is Y. So the answer is Y. So that is the element in the D block of the transition metal. I hope you understood all of that before we go to the next topic. This question says, on evaporation to dryness, 350 cm³ of saturated solution of salt, Z, gave 55.5 grams of salt. What is the solubility in mole per dm³? So this topic is solubility. And basically, solubility can be defined in 3 ways. I've done a complete video on solubility. I will also drop the link to the description to this video. But so as not to take time, I'll just give you a short formula you can use to answer questions on solubility. Now, there is a relationship between solubility and stoichiometry, mole concept. So when they are asking you to find the solubility, they are simply asking you to find the concentration of the substance, of the acid or the salt, wherever. You are looking for the concentration. And how do you get the concentration? You can derive the formula of solubility from the formula of mole concept. Now, if you can still recall your mole concept, I gave you equation 1 to be number of mole equals mass over molar mass. Number of mole is equals to mass over molar mass. and then I gave you number of mole is equals to molar concentration times volume in dm cube. So when they ask you for solubility, they are simply asking you for molar concentration. So here, the short form of this is N, number of mole equals CV, molar concentration times volume. So when they ask you for solubility, they are asking you to make C the subject of formula. So your C is going to be N over V. But you recall that your N number of mole is the same thing as mass over molar mass. So here, I can as well say, instead of this N, I'll say mass over molar mass, okay, is equals to CV. Then if I make my C the subject of formula, I will get the solubility. So my solubility C. So solubility, the formula for solubility using this C, solubility C is N. What is my N? Mass over molar mass. Mass over molar mass divided by this V. Volume in what? dm cube. So this is the formula for solubility. You can either use this, remember volume in dm cube. So if I want to change this division now to multiplication, it will be what? Solubility is equals to mass over molar mass times 1 over V in dm cube. So this is one formula. Because I've changed this division to times, I will have to find the reciprocal. When we go up, this comes down. So this formula is used to find solubility, or you remember this is divided by V in dm cube. So, or my solubility, which is equal to mass over molar mass divided by V in dm cube. My V in dm cube. Now, if I want to convert from centimeter cube to dm cube, so another formula you can use is this dm cube. If I convert from centimeter cube to dm cube, because volume can be measured in liters, is cm cube in dm cube. So to convert from cm cube to dm cube, you divide that centimeter cube by 1000. So that means everything here is the same thing as volume in centimeter cube divided by 1000. So I can rewrite that as solubility equals mass over molar mass divided by volume in centimeter cube over 1000. Or everything here now is equivalent to volume in dm cube. So if I want to change this division now to multiplication, we have solubility is equals to mass over molar mass times 1000 will go up over volume in cm cube. This is the second formula for calculating solubility. So either of these two, you get your answer. So now we are going to use the two to answer this question, and let's see what the answer will be. So if we are going to do this, because our volume is in centimeter cube, so let's try this formula first. So the question on evaporation to dryness, 350 cm cube of saturated solution salt gave 55.5 grams. So the mass is 55.5 grams. The volume in cm cube is 350 cm cube. Those are parameters. Then this is the molar mass. Molar mass is 101. All right. So let's slot in the value. So our solubility will be mass is what? 55.5 divided by molar mass, which is 101, times 1000 over V in centimeter cube is 350. If you calculate this correctly, the answer is going to be 1.57 mole per dm cube. 1.57 mole per dm cube, and that's in the option. And if we try this second formula, okay, or if you try this second formula, your solubility will be mass is what? 55.5 divided by molar mass 101 times 1 over this V now has to be in dm cube. So you convert this 350 to dm cube by dividing by 1000. That will be 0.35. If you multiply this, you get 1.57 mole per dm cube. That's the answer. So that is the basic simple formula to answer questions on solubility. Now, it's also important to note they can ask you to define solubility. There are basically three definitions for solubility. Number one, solubility is the amount of a substance in moles, or I can as well say amount of a solute in moles present in 1 dm cube of solution. Amount of a solute is the solid, solvent is the liquid. When you dissolve the solute in the solvent, you have the solution. So the mixture of the two is solution. For example, salt, sodium chloride, table salt plus water. The salt is the solute, your water is the solvent. Mixing the two together, the salt solution is the solution. So amount of solute, that's the amount of the salt in moles present in 1 dm cube of solution. That is solubility in mole per dm cube. I can also define solubility as amount of solute in grams present in 1 dm cube of solution. This second formula or this second definition will give you mass concentration. That's the solubility in gram per dm cube. So if they ask you to find in gram per dm, this one is in mole per dm cube. Why is it mole per dm cube? Because it's amount in moles. These are amount in grams. And the third one is amount in grams. The third one is amount of solute in grams present in 1000 grams of solution. Amount of solute in grams present in 1000 grams of solution. That is the third definition of solubility. So if they ask you to define it, either of these three or all of the three are very correct. And that is clear.